Hello, people, and welcome to the Sleepy Science Lab. Tonight, we drift far beyond the Milky Way to meet a silent giant shining in the dark, the Andromeda Galaxy. To the unaided eye, Andromeda appears as nothing more than a soft, hazy blur against the night sky. But in truth, it is an enormous realm, home to over 1 trillion stars. Its graceful arms sweep across hundreds of thousands of light years, glowing faintly through the endless black of space. The light reaching your eyes tonight began its journey more than 2 million years ago, long before the first humans walked the Earth. Every shimmering ray carries the story of a distant sun, a drifting cloud of dust, or perhaps a world no one will ever set foot on. Within those immense spirals, stars are being born, colliding and fading into darkness. Andromeda is not just a point of light, it's our nearest great galactic companion, slowly making its way toward us through the cosmic void. Billions of years from now, it will merge with our Milky Way, creating something entirely new. If you enjoy these calm cosmic journeys, take a moment to like, subscribe, or share your thoughts below. It helps other sleepy explorers find their way here, one peaceful soul at a time. For now, let your body relax, your breathing slow, and your thoughts drift free. Let the universe cradle your mind as we begin tonight's journey. Andromeda, our neighbor in the stars. Among the countless galaxies scattered across the cosmos, Andromeda stands out as our closest large spiral neighbor, lying just over 2 million light-years away. Though that distance is unimaginable, in the scale of the universe, it is astonishingly close enough to study in remarkable detail. Through the gaze of powerful telescopes, Andromeda's structure unfolds in breathtaking clarity. Its glowing disk stretches across space, with dark lanes of dust weaving through rivers of starlight that spiral toward its core. Each image offers a glimpse of order and beauty, a reflection of what our own Milky Way might look like to someone far away. Because of this nearness, Andromeda has become one of the most carefully studied galaxies in modern astronomy, a living laboratory showing how galaxies form, evolve, and interact. In its light, we see not only a neighbor, but a preview of our galaxy's distant destiny, written quietly across the night. A galaxy of 1 trillion suns. Inside Andromeda's vast spirals lie more than 1 trillion stars, each burning with its own rhythm and color. From the crowded central bulge of ancient suns to the farthest spiral arms where new stars are born, it is a world of unimaginable scale. Some stars are enormous blue giants, burning fiercely before exploding in brilliant supernovae that scatter heavy elements into space. Others are tiny red dwarfs, glowing dimly and steadily, destined to shine for trillions of years. Together, their combined light travels across millions of light years, giving Andromeda its glow and its immense gravitational pull. If even a small fraction of those stars host planets, then the number of possible worlds within Andromeda defies comprehension, perhaps more than all the grains of sand on Earth's beaches. sky. From Earth, you can see Andromeda with your own eyes. On a clear, moonless night, far from city lights, look toward the constellation Andromeda. There it appears, a soft oval blur glowing faintly in the darkness. That ghostly shimmer isn't a trick of vision. It's the combined light of 1 trillion suns. Ancient stargazers saw it as a mysterious cloud, neither star nor planet, hovering at the edge of awareness. Only with the invention of telescopes did humanity realize its true nature. Not a cloud, but an entire galaxy beyond our own. When you find Andromeda in the night sky, you're seeing light that left its home millions of years before recorded history. The same light witnessed by generations long before us. It's a bridge across both space and time, connecting us to the vastness of the universe and to those who gazed upward centuries ago. From nebula to galaxy, a discovery that changed everything. For centuries, astronomers believed Andromeda was merely a cloud within our Milky Way, a nebula adrift among the stars. Early telescopes could only show a faint patch of light, leading many to think it was a small pocket of gas and dust. That belief endured until the 1920s, when Edwin Hubble, using the 100-inch telescope at Mount Wilson Observatory, looked deeper. Within the haze, he identified a special type of star, a Cepheid variable, whose rhythmic brightening and dimming revealed its true distance. The results were astonishing. Andromeda wasn't within our galaxy at all. It was millions of light years away, a galaxy in its own right. This discovery forever transformed our understanding of the cosmos, proving that the universe is far larger than we ever imagined, a sea of galaxies beyond counting. A glimpse into the distant past. When we look at Andromeda tonight, we are seeing it not as it exists now, but as it appeared more than 2 million years ago. Every particle of light reaching our eyes began its journey before the first humans walked the Earth. Some of the stars that emitted that light may have already faded or exploded, yet their glow travels on, unchanged. Observing Andromeda is like looking through a cosmic window. The light entering our telescopes tonight began its voyage when early humans were shaping stone tools beneath the ancient African sky. Each observation connects us not only to science, but to the deep story of time itself. A reminder that light is history, traveling endlessly through the universe to find us. A silent collision course. Though Andromeda appears still and peaceful, it's actually racing towards us at over 200 kilometers per second. Astronomers discovered this motion through the blue shift in its starlight, a subtle compression of light waves that reveals its approach. This is rare. Most galaxies are drifting away as the universe expands, but Andromeda is one of the few moving directly toward the Milky Way, drawn by the invisible pull of gravity. It's a slow-motion cosmic dance that has already begun, silent, unstoppable, and written into the fabric of space itself. In its quiet advance, we glimpse both our galaxy's future and the majestic choreography of gravity that shapes the universe. The future, a galactic merger. Astronomers have mapped this celestial journey using observatories like Hubble and Gaia, confirming that Andromeda is on a collision course with our galaxy. In about 4 billion years, the two will begin their first close encounter, drawn together by mutual gravity. Over time, their spiral arms will stretch and twist, forming vast rivers of stars before merging into a single luminous structure. Despite the dramatic scale, most stars won't collide. There's too much empty space between them. Instead, their orbits will shift, creating new patterns of light and motion. Eventually, the Milky Way and Andromeda will fuse into a new, larger elliptical galaxy, one astronomers have already named Milkomeda.
The spiral arms of Andromeda are not fixed, solid structures. They are living waves of motion, rippling through the galaxy like vast tides in space. As these waves pass through regions rich in gas and dust, they compress the material, igniting bursts of star formation that light the arms with clusters of young blue stars. Between these glowing ribbons lie dark lanes of dust which absorb and scatter light, adding depth and texture to the galaxy's majestic design. Viewed through powerful telescopes, these arms reveal a breathtaking dance, a cycle where matter flows, collapses, and renews itself over immense spans of time. Within these spirals lies a delicate balance between order and chaos, a constant interplay that keeps galaxies alive and ever-changing, shaped by the quiet pull of gravity. A galaxy of giant proportions. Andromeda dwarfs our own Milky Way in both size and scale. Through a telescope, its immensity becomes almost impossible to grasp. The galaxy's disk stretches over 220,000 light-years from end to end, nearly twice the width of the Milky Way, and holds more than 1 trillion stars. Beyond the visible glow lies a faint halo that fades into the deep black of intergalactic space. If our eyes could perceive all its light, Andromeda would appear several times wider than the full moon in our night sky. It's a humbling sight, a reminder that galaxies are not neat spirals of light, but sprawling cosmic cities built from countless stars, nebulae, and invisible matter. Compared to Andromeda, our Milky Way seems like a younger, smaller sibling, both bound by gravity, destined to one day meet in a magnificent cosmic embrace. The golden heart of Andromeda. At the very center of Andromeda lies a brilliant golden core, glowing brighter than nearly any other region in the galaxy. This heart is a dense city of ancient suns, stars that have burned for billions of years, smaller and steadier than our own sun, their fuel slowly fading. Packed so tightly that in some areas they are only a fraction of a light year apart, these stars form a glowing hub whose light takes over 2 million years to reach our eyes. That golden hue tells astronomers something profound. It marks an older population of stars, born in the galaxy's earliest days. The frenzy of starbirth here has long subsided, leaving behind a glowing fossil of Andromeda's ancient past, a soft, enduring light that has watched the universe change around it. The dark heart, Andromeda's supermassive black hole. At the very center of this golden core, astronomers have detected stars moving at incredible speeds around something unseen. The only possible explanation is the presence of a supermassive black hole, millions of times heavier than our sun. Its gravitational pull is so immense that not even light can escape once it crosses the black hole's boundary. Around this invisible engine, stars orbit in a breathtaking cosmic ballet, their motions shaped by gravity's silent hand. Clouds of hot gas and dust swirl nearby, glowing fiercely as they spiral inward, a final luminous dance before disappearing forever. Though we cannot see the black hole itself, its existence is written in the movements of the stars and the radiation emitted by its surroundings. A hidden power that shapes the galaxy's rhythm and holds its heart together. A possible duo, two black holes in one galaxy. When astronomers looked even closer at Andromeda's core using high-resolution instruments, they found something astonishing: two bright sources of light instead of one. This discovery led to a bold theory. Andromeda may harbor two supermassive black holes, locked in an ancient, slow-motion dance around each other. Such a pair could be the remnants of a long-ago galactic merger, when two ancient galaxies collided and their central black holes began spiraling together. Over billions of years, they may drift closer, releasing subtle gravitational waves that ripple through space-time itself. Eventually, they will merge into a single, even more massive black hole, an event of unimaginable power. If this is true, Andromeda's hidden double heart offers us a glimpse into our own galaxy's future, when the Milky Way's central black hole will one day meet Andromeda's in a similar cosmic union. The ghostly halo, Andromeda's invisible edge. Beyond its bright spiral disk lies a vast, invisible realm, a halo stretching more than 1,000,000 light-years from Andromeda's center. It cannot be seen with human eyes. It is mostly made of thin gas, scattered dust, and mysterious dark matter. Within this faint envelope drift ancient star clusters and stellar streams, the remains of long-vanished galaxies once consumed by Andromeda. Astronomers study this ethereal region through ultraviolet and X-ray observations, detecting faint traces of atoms energized by distant starlight. Though almost ghostly, the halo is essential, a reservoir of raw material and a boundary marking the true edge of the galaxy's influence. It is Andromeda's invisible aura, blending gently into the intergalactic medium that fills the vast spaces between galaxies. A connection already begun. The Milky Way and Andromeda are separated by over 2 million light-years of apparent emptiness, yet recent discoveries suggest that their outer halos are already touching. These vast, unseen atmospheres of plasma and dark matter overlap, meaning the two galaxies are already interacting, long before their stars will ever meet. It's as though their invisible edges have begun to whisper across the void, exchanging energy and particles in the dark. This quiet merging reminds us that space has no sharp borders. Galaxies begin to influence one another long before the dramatic spectacle of collision. Even now, the earliest threads of their union are forming, weaving the first hints of the great merger yet to come. The warped disk, ripples in a galactic sea. When astronomers mapped the stars and gas within Andromeda, they discovered something remarkable. The galaxy's disk is not flat. Instead, it bends and twists like a frozen ripple on the surface of a cosmic pond. Parts of the disk rise and fall by thousands of light-years, a signature of powerful gravitational forces at work. Such warps often occur when galaxies interact or collide. The pattern of distortion in Andromeda's structure suggests that beneath its calm spiral beauty lies a turbulent past, evidence of ancient encounters and gravitational tides that reshaped its form. Even across millions of light-years, we can see the lingering echoes of these events etched in the stars like ripples in time. A reminder that no galaxy, however serene it appears, is ever truly still. Scars of ancient collisions. These distortions are not random bends, they are scars of cosmic encounters. Long ago, smaller galaxies may have drifted too close to Andromeda, torn apart by its immense gravity. Their remnants were stretched into glowing streams and absorbed into the larger whole. Over billions of years, these interactions warped the once flat disk, leaving behind the gentle curve we see today. By studying these subtle patterns, scientists can reconstruct Andromeda's history, tracing the remains of galaxies that vanished long before life appeared on Earth. Each ripple, each faint loop of stars is a memory, the quiet signature of creation through collision. A family of companions. Like our own Milky Way, Andromeda is not alone. It is surrounded by a swarm of smaller companion galaxies, known as satellite galaxies, orbiting at various distances. Some are bright and distinct. Others are faint smudges visible only through powerful telescopes. These companions, many of them dwarf galaxies rich in old stars, dance under Andromeda's gravitational pull, slowly drawn inward over cosmic time. Their motion reveals how large galaxies grow and evolve, gathering smaller systems into their orbit and eventually absorbing them. The space around Andromeda is therefore far from empty. It is alive with motion, filled with tiny galaxies slowly circling their colossal neighbor. Cosmic cannibalism, creation through destruction. Many of these companion galaxies are being gradually consumed. As Andromeda's gravity tugs on them, their stars and gas stretch into long tidal streams that spiral into the galaxy's main body. This slow, silent process, known as galactic cannibalism, is one of the universe's most common and creative forces. Through it, galaxies grow, reshaping themselves by devouring their smaller neighbors. Around Andromeda, astronomers have detected faint arcs and ghostly trails of stars, the remains of once independent galaxies, now part of something far greater. Even now, somewhere within Andromeda's vast halo, new streams are forming as tiny galaxies yield to its gravity. Through their sacrifice, Andromeda continues to evolve, a living example of how destruction and creation are woven together in the story of the cosmos. Stars from other galaxies. Not every star shining within Andromeda was born there. Many began their lives in smaller galaxies that were later captured or merged.
It was the moment that forever changed how humanity saw the universe. When Edwin Hubble looked deeper into the night sky, he opened a window into infinity, revealing that our Milky Way was not the entire cosmos, but just one of countless galaxies scattered across the endless fabric of space. By studying the light from Cepheid variable stars, Hubble discovered that Andromeda was over 2 million light-years away, a distance so vast it shattered every prior belief about the limits of creation. In an instant, the known universe expanded beyond imagination. Andromeda became the first confirmed galaxy beyond our own, proof that we were not alone in the vast darkness. This discovery marked the birth of modern astronomy. For the first time, humanity grasped that the sky above was not a single island of stars, but an entire cosmic ocean, filled with galaxies of every shape and size, drifting endlessly through space. Hubble's measurements not only revealed Andromeda's true nature, but hinted at a greater truth, that the universe itself was grander, older, and more dynamic than anyone had ever dreamed. When Hubble announced his results in the 1920s, the scientific world was stunned. The cosmos, once thought to end with the Milky Way, suddenly expanded into a vast, unbounded sea of light. Overnight, humanity's perspective shifted from local to universal, from a single city of stars to an infinite archipelago of galaxies. It was more than a discovery. It was an awakening, a revelation that redefined our place in existence, reshaping how we understood scale, time, and possibility. But Hubble's journey didn't end there. As he continued to study other galaxies, he noticed something extraordinary. Their light was stretched toward the red end of the spectrum, a sign that they were moving away from us. From this, he deduced one of the most profound truths in science. The universe itself is expanding. Andromeda, however, was a rare exception. Instead of retreating, it was drawing nearer, moving toward us at astonishing speed. This made it even more significant. It proved that galaxies are not still, but alive, drifting, colliding, and merging in a vast cosmic dance. Andromeda became both a neighbor and a key to understanding the universe's grand motion, a silent witness to the truth that even space and time themselves are constantly evolving. To measure these immense distances, Hubble relied on the remarkable Cepheid variable stars, cosmic beacons that pulse in brightness with rhythmic precision. Each heartbeat of light reveals exactly how bright the star truly is. By comparing that intrinsic glow with its faint appearance from Earth, astronomers can determine how far away it lies. Andromeda was where this method, the cosmic distance ladder, began. Those stars turned light itself into a ruler, allowing humanity to chart the universe one rhythm at a time. Every modern measurement of galaxies, clusters, and cosmic expansion traces its roots back to those first flickering Cepheids in Andromeda. Their steady pulses became the heartbeat of the cosmos, a rhythm echoing through millions of years of space and time. When Hubble compared their brightness to their faint light as seen from Earth, the result was undeniable. These stars were far too dim to exist within our Milky Way. Andromeda was not a local nebula, but a galaxy of its own, millions of light-years distance. Each tiny pulse of light had been traveling toward us since before the dawn of humanity, crossing unimaginable gulfs of emptiness to tell its story. That faint starlight became a message from the ancient past, proof that the universe was far larger and more wondrous than we had ever imagined. In a single realization, the scale of existence exploded outward. The Milky Way was no longer all of creation, but one among billions of galaxies, each filled with its own suns, planets, and possibilities. Humanity suddenly understood that it occupied a modest world circling an ordinary star within a single galaxy, itself just a speck in an endless cosmic ocean. It was a moment of awakening, on par with the discovery that Earth orbits the Sun, a revelation that reshaped not only science, but the human spirit itself.
Some of Andromeda's stars contain fewer heavy elements, ancient travelers born in primitive galaxies long before Andromeda took shape. Together, they reveal that this galaxy wasn't built in isolation, but through a long and complex history of mergers. Each new addition brought its own story, its own chemistry, and its own starlight, weaving a magnificent cosmic tapestry made from countless threads of time and space. Trailing far beyond the galaxy's edges are ghostly streams of stars, the lingering remains of smaller galaxies that were torn apart and absorbed by Andromeda's gravity. These faint ribbons of light stretch for hundreds of thousands of light years, tracing the exact paths those lost galaxies once followed. By mapping their motion, astronomers can piece together Andromeda's ancient encounters, uncovering the hidden record of collisions that shaped its present form. Each stream is like a fossil frozen in light, a delicate reminder of creation through destruction, written across the darkness of the cosmos. As we study Andromeda more deeply, its story grows clearer. This galaxy is the product of countless acts of cosmic cannibalism. Its warped disk, scattered halo, and faint debris all speak of galaxies long devoured. Every ripple and distortion marks the slow gravitational feast that built it over billions of years. Yet this process is not violent like we might imagine. It's the quiet metabolism of the universe, galaxies merging, stars recycled, and light reborn. Andromeda's beauty, then, is not static. It's a portrait of eternal transformation. But beneath all that glowing starlight lies a far deeper mystery: dark matter. Only a small portion of Andromeda's total mass comes from stars, gas, and dust. The rest, the vast majority, is something unseen. This invisible substance neither emits nor reflects light, yet its gravitational pull binds the galaxy together. Without it, Andromeda's outer stars would drift away into space. Scientists call this hidden mass dark matter, an enigma that challenges our understanding of physics itself. It may be made of exotic particles, or it may hint at deeper cosmic laws still undiscovered. Whatever it is, dark matter forms a massive, transparent cocoon around Andromeda, connecting it to every other galaxy through an unseen web of gravity that stretches across the universe. When astronomers calculate Andromeda's full mass, they find that dark matter outweighs its visible stars and gas by nearly 10 to 1. It shapes how the galaxy spins, stabilizes its structure, and holds its spiral together. Even though we can't see it, its presence is undeniable, revealed in the way stars orbit faster than they should, moving in harmony with an invisible force. Andromeda becomes not just a sea of light, but a vast gravitational mystery suspended in the dark. Scattered across its spiral arms are immense clouds of glowing hydrogen, the raw material for new stars. When these clouds are energized by starlight, they shimmer in soft pink and red hues, forming breathtaking nebulae that stretch for thousands of light years. Within them, gravity gathers dense knots of gas until they ignite in fusion, giving birth to new suns. These are the stellar nurseries of Andromeda, cosmic cradles where light is born anew. The light from these nebulae travels for over 2 million years before reaching us, a time capsule showing Andromeda's present as it once was long ago. Within these vast nurseries, the cycle of creation and death continues every day, unfolding again and again. Clouds collapse, stars ignite, and radiant clusters illuminate the darkness. Their ultraviolet light carves intricate shapes into surrounding gas, sculpting glowing arcs and filaments. Some of these stars live short, brilliant lives before exploding as supernovae, while others endure quietly for billions of years. Observing these regions is like looking back at our own beginning, at the process that once gave birth to the sun itself. High above Andromeda's shining disk, astronomers have detected enormous bubbles of hot gas, each tens of thousands of light years across. These ghostly giants glow in X-rays, evidence of powerful energy released from within the galaxy's heart. They may have formed through waves of supernovae or massive bursts of star formation, pushing gas outward like a galactic exhale. These bubbles reveal how galaxies breathe, creating, releasing, and renewing their energy across eons. Though invisible to the naked eye, they are silent proof that even galaxies live dynamic lives, pulsing and reshaping the space around them. Sometimes Andromeda erupts in starbursts, brief but intense surges of creation when thousands of new stars are born in rapid succession. These energetic episodes flood the galaxy with radiation and cosmic winds, inflating enormous bubbles above and below its disk. Over time, these bursts enrich the galaxy's halo with heavier elements, the very ingredients for future stars and planets. In this way, Andromeda is not a static structure, but a living ecosystem that breathes, burns, and evolves with time. Every burst of energy becomes part of its long, unfolding story. Across Andromeda, the cycle of life and death continues. Stars live for billions of years, but every so often, one ends in a spectacular explosion, a supernova. In an instant, it releases more energy than our sun will emit in its entire lifetime. Each explosion stirs the surrounding gas, seeding it with heavy elements like iron, oxygen, and gold, the building blocks of future worlds. Through this endless rhythm of destruction and rebirth, Andromeda keeps renewing itself. Its beauty, visible from millions of light years away, is the result of an ancient cosmic heartbeat. When viewed through powerful telescopes, Andromeda's spiral arms glitter with countless young blue stars, dazzling beacons of youth and energy. They burn fiercely and live fast, illuminating the galaxy's graceful spirals with radiant light before fading in supernova glory. These blue stars mark the newest chapters of Andromeda's ongoing creation,
brilliant reminders that even in the vast silence of space, the universe is still alive, still creating, and still shining with endless wonder. At the very heart of the Andromeda Galaxy lies a world strikingly different from its radiant spiral arms. Here, the light softens into warm shades of gold and red, cast by ancient stars that have burned for billions of years. These older suns, having long exhausted much of their hydrogen, now glow with quiet steadiness, their energy fading yet enduring. Together, they form the gentle amber core that defines Andromeda's bulge. Star formation here has slowed to a whisper, leaving behind a dense population of mature stars orbiting the galaxy's hidden black hole in intricate paths. Studying this region gives astronomers a glimpse into Andromeda's earliest epochs, the calm that follows the storm of stellar birth. The contrast between the golden heart and the blue spiral arms is more than just color. It's a story of time itself, how galaxies age, mellow, and settle into quiet brilliance as their energy slowly fades with the passing of cosmic years. But Andromeda's story of creation is far from uniform. Its spiral arms may look symmetrical from afar, yet star formation dances unevenly across its disk. Some regions blaze with clusters of newborn stars, while others lie still and dim. This patchwork of activity is shaped by the galaxy's internal rhythms, the interplay of gas, dust, and magnetic fields. Where cold hydrogen gas gathers thickly, gravity ignites new stars. Elsewhere, the gas may be too thin or too warm to collapse. As waves of density sweep through the spiral arms, they compress the gas in rhythmic pulses, sparking fresh bursts of light along the curved bands. Each glittering arc is part of this vast celestial rhythm, a heartbeat of creation that ebbs and flows across the galaxy. Through these patterns, astronomers glimpse how galaxies breathe, not in steady motion, but in cycles of calm and creation. In Andromeda's core, time moves differently. The inner regions have grown quieter, their star-forming fuel long since consumed or expelled by powerful stellar winds. Now, older, long-lived stars dominate, glowing softly with the wisdom of age. Yet farther out, along the spiral arms, the galaxy still teems with youthful energy. Cold hydrogen clouds continue to collapse and give birth to new stars, painting the outskirts in flickering blue light. This layering of time, an ancient heart surrounded by a youthful rim, tells the story of how galaxies evolve. Even as the core grows still, the edges pulse with renewal, reminding us that the cosmic cycle of life never truly stops. Threaded through those brilliant arms are delicate lanes of dust, swirling like smoky ribbons across Andromeda's glowing face. These streaks are made of microscopic grains of carbon and silicate, the ashes of long-dead stars. They twist and coil along the spiral structure, scattering and absorbing starlight, creating intricate patterns of shadow and glow. But these dark lanes are not lifeless. They are nurseries, the fertile soil from which future stars will rise. Seen through infrared telescopes, these dusty bands come alive, glowing faintly with warmth as they soak in nearby starlight. Within their folds lies the quiet choreography of creation, the same process that once gave birth to our own sun and earth. Every grain, every swirl of dust carries the memory of the stars that came before. Through the eyes of infrared telescopes like Spitzer and James Webb, what once looked like darkness reveals itself as gentle radiance. The dust that appears as shadow in visible light glows softly in the infrared, revealing hidden clusters of newborn stars still wrapped in their birth clouds. These warm, luminous veins trace Andromeda's hidden architecture, a vast glowing web of gas and dust shaping the spiral arms from within. Even in the coldest corners of space, nothing is ever truly still. Every shadow hides warmth, every silence vibrates with energy, and every grain of dust holds the promise of future light. When astronomers shift their view to ultraviolet light, Andromeda transforms again. Its spiral arms blaze with fierce blue-white energy, revealing regions crowded with massive newborn stars. These stellar nurseries emit intense ultraviolet radiation that sculpts the surrounding gas into bright, glowing arcs. Each brilliant patch marks a cluster of stars less than a few million years old, cosmic cradles where creation is happening right now. To see Andromeda in ultraviolet is to witness its pulse of youth, a living, breathing galaxy still creating new light amid the ancient calm of its core. But before these stars come to life, their raw material exists as vast, invisible oceans of cold hydrogen gas. These regions don't shine in visible light, but they whisper across the cosmos in faint radio waves. By tuning in to the specific frequency of neutral hydrogen, astronomers can map Andromeda's hidden reservoirs of star-forming material. The resulting radio images reveal sprawling spiral arms that stretch far beyond the visible edge of the galaxy, a blueprint of its future. This cold gas is Andromeda's reserve of tomorrow's stars, quietly waiting for gravity to awaken it. In the radio view, we don't just see the present, we glimpse the galaxy's destiny. Andromeda radiates across the entire electromagnetic spectrum, from long radio waves to powerful gamma rays. Each wavelength reveals a new layer of its personality. Radio signals expose its cold gas and hidden structure. Infrared unveils the warmth of dust and newborn stars. Visible light displays the grand spiral itself. Ultraviolet captures the fire of youth, and X-rays expose the violent aftermath of exploding suns. Only by combining all these views can astronomers see the whole truth, a living masterpiece woven from birth and death, light and shadow, energy and silence. To gaze upon Andromeda across the spectrum is to witness the full story of cosmic life, all in one vast, breathtaking frame. Because of its proximity and grandeur, Andromeda is one of the most studied galaxies in the universe. The Hubble Space Telescope has mapped its sweeping spirals in exquisite detail, while Chandra's X-ray Observatory and the James Webb Space Telescope have explored its energetic heart and dusty outskirts. Each observation adds another brushstroke to our understanding of how galaxies form, age, and evolve. Andromeda isn't just another smudge in the night sky. It's a cornerstone of astronomy itself, a mirror through which we study not only other galaxies, but the history and future of our own. Centuries ago, though, Andromeda was a mystery. Through early telescopes, it appeared only as a faint, misty patch, the Great Andromeda Nebula. Astronomers argued fiercely. Was it a small cloud of gas within the Milky Way, or something unimaginably larger beyond it? For generations, this debate reflected humanity's growing hunger to understand the universe. We could see Andromeda with our eyes, yet we had no idea how far away it truly was, or how vast. Then came the photograph that changed everything. In the early 20th century, astronomer Edwin Hubble captured a long-exposure image of Andromeda through the Hooker telescope at Mount Wilson Observatory. Within its spirals, he discovered faint, rhythmic points of light, Cepheid variable stars. By measuring their brightness and pulse, Hubble calculated their distance, and the result stunned the world. These stars lay far beyond the Milky Way. Andromeda wasn't a nearby nebula, it was a galaxy, a vast island universe all its own. That single photograph forever transformed astronomy, expanding our understanding of space and revealing that our Milky Way was not alone. The cosmos had just grown infinitely larger.
Their steady pulses became the heartbeat of the cosmos, a rhythm echoing through millions of years of space and time. When Hubble compared their brightness to their faint light as seen from Earth, the result was undeniable.
These stars were far too dim to exist within our Milky Way. Andromeda was not a local nebula, but a galaxy of its own, millions of light years distant. Each tiny pulse of light had been traveling toward us since before the dawn of humanity, crossing unimaginable gulfs of emptiness to tell its story. That faint starlight became a message from the ancient past, proof that the universe was far larger and more wondrous than we had ever imagined. In a single realization, the scale of existence exploded outward. The Milky Way was no longer all of creation, but one among billions of galaxies, each filled with its own suns, planets, and possibilities. Humanity suddenly understood that it occupied a modest world circling an ordinary star within a single galaxy, itself just a speck in an endless cosmic ocean. It was a moment of awakening, on par with the discovery that Earth orbits the Sun, a revelation that reshaped not only science, but the human spirit itself. Andromeda's story didn't end with that revelation. It continues to evolve. Unlike most galaxies that drift away as the universe expands, Andromeda is moving toward us, racing closer at more than 200 kilometers per second. This subtle blue shift in its light reveals its direction, an approach guided by the invisible pull of gravity between our two galaxies. Though the distance remains immense, the fate is certain. In about 4 billion years, Andromeda and the Milky Way will collide. But this will not be a violent crash. It will be a slow, graceful merger unfolding over billions of years. Their stars will pass harmlessly through each other, their spiral arms stretching into elegant arcs of light. Gravity will weave them together, blending gas and dust into new patterns, sparking waves of fresh star formation. From this grand cosmic ballet will emerge a new, larger galaxy, sometimes called Milkomeda, glowing quietly in the night of a distant future. This coming union is not a catastrophe, but a transformation, a reminder that even on a galactic scale, creation is a process of renewal. As their halos already begin to mingle, exchanging whispers of gas and dark matter across the void, Andromeda and the Milky Way remind us that nothing in the universe stands still. Everything from stars to galaxies is part of a cosmic rhythm, a slow and beautiful dance of change that has been unfolding since time began. Andromeda's light continues to reach us, a silent message from the future of our own galaxy. Each shimmer we see through a telescope carries not just photons, but history, destiny, and connection. It tells us that we are part of something vast, ancient, and alive, a universe still growing, still merging, and still full of wonder.
When galaxies collide, their stars rarely do. Even though both the Milky Way and Andromeda contain hundreds of billions of stars, the distances between them are so immense that direct collisions are nearly impossible. If the two galaxies were to overlap completely, the chance of any two stars physically striking each other would be almost zero. Instead, their meeting will be a graceful dance of gravity. The orbits of stars will twist and shift under the combined pull of both galaxies. Some will be flung outward into long tidal streams stretching thousands of light years across, while others will spiral inward toward a shared galactic center. Meanwhile, vast clouds of gas will collide and compress, triggering bursts of new star formation. From afar, it will look less like destruction and more like creation, a slow, cosmic embrace where two shining spirals merge into one radiant entity, glowing serenely amid the endless dark. When Andromeda finally meets the Milky Way,
gravity will sculpt a breathtaking new landscape. Stars that once moved in perfect circular paths will begin tracing elegant arcs through the merged gravitational field. Some will be cast into sweeping loops that extend beyond the galaxy's edge, while others will spiral inward, forming a brilliant glowing core. Over time, the two graceful spirals will lose their symmetry, blending into a single elongated structure. After the initial chaos, their billions of stars will settle into calm, stable orbits once again, guided by the gentle hand of gravity. From Earth, the night sky of that distant future will be spectacular. If humanity, or its descendants, still exist billions of years from now, they'll witness a cosmic show beyond imagination. As Andromeda approaches, it will appear larger and brighter each night, transforming from a faint blur into a glowing, majestic disk. Eventually, its spiral arms will be visible to the naked eye, painting the heavens with vast, curving bands of light. During the merger, rivers of stars will streak across the sky like molten fire, creating a view both surreal and sublime. Though this transformation will unfold slowly over millions of generations, its beauty will be unmatched, a celestial ballet of light and time. The stars will not disappear, they'll simply rearrange, forming new constellations. The future night will shimmer with evidence that galaxies, like living things, are born, evolve, and unite, leaving behind luminous echoes of their union. As the galaxies draw closer, gravity will stretch their spiral arms into colossal arcs of light called tidal streams, each one containing billions of stars stretched thin across intergalactic space. Some will eventually drift back toward the core, while others will become faint ribbons of starlight lost to the void. Astronomers have already seen such patterns in other galaxies, giving us a glimpse of what our own cosmic merger will look like. These glowing bridges of light will endure for billions of years, delicate reminders of the invisible pull that brought two galaxies together and reshaped them into one. Eventually, the Milky Way and Andromeda will settle into a single enormous elliptical galaxy, a vast glowing spheroid filled with the combined stars, gas, and dark matter of both. Even their central black holes may merge, releasing powerful waves of gravitational energy that ripple across the universe. Astronomers have already given this future galaxy a poetic name, Milkdromeda. The entire process will span billions of years, not a single dramatic collision, but a long, elegant transformation. The galaxies will pass through one another, drift apart, and then be pulled back again, their shapes distorting with every encounter. New stars will be born, old ones will fade, and over time their motion will settle into a serene equilibrium, a monument of starlight sculpted by time itself. Our solar system will likely survive this great event unharmed. Despite the enormity of the merger, the space between stars is so vast that the Sun and its planets will simply drift to a new position within the reshaped galaxy. Earth may find itself beneath unfamiliar constellations, orbiting quietly in a transformed night sky, but life here will go on. From our perspective, the galactic collision that seems so cataclysmic will unfold almost gently. The sun will continue to shine, Earth will continue to turn, and the sky will remain full of stars. Perhaps civilizations in Andromeda already know of us. If intelligent beings exist there, their telescopes might already be aimed toward the Milky Way. But from their point of view, they would see our galaxy as it was more than 2 million years ago, long before humanity appeared. To them, Earth would still be a young, wild world bathed in starlight, untouched by civilization. And just as they see our ancient past, we see theirs. Every glimpse we take of Andromeda is a look back through time, an image of what it once was, not what it is now. The light that reaches us carries the memory of an earlier universe, where both galaxies were younger, brighter, and full of promise. Even if civilizations in Andromeda tried to reach out, communication would be nearly impossible. A message traveling at the speed of light would take over 2 million years to reach us, and another 2 million for a reply. By the time the second message arrived, both civilizations might have changed beyond recognition or vanished entirely. Yet the idea itself is profound. Every beam of light, every signal across the void is a message from the past, a whisper cast into the cosmic dark. Across those unimaginable distances, the universe listens in silence, patiently waiting. And somewhere, perhaps within the swirling arms of Andromeda, countless planets may orbit beneath alien suns, some rocky and temperate, others icy or shrouded in cloud. Many could host oceans, atmospheres, or even life. Though we can't see them yet, science suggests there may be millions of Earth-like worlds scattered throughout Andromeda, each carrying its own story, its own possibility. Someday, new telescopes may reveal faint signatures of oxygen, methane, or water, signs that life, in some form, thrives beneath its stars. The universe is vast, creative, and patient, forever weaving its stories of birth, transformation, and connection among the stars.
Not every star in Andromeda mirrors the familiar warmth of our sun. Some are colossal blue giants, blazing with intense ultraviolet light, burning so fiercely that they exhaust their fuel in just a few million years. Others are tiny red dwarfs, cool and dim, capable of glowing softly for trillions of years, long after every other star we know has faded away. Planets orbiting these stars would live under entirely different skies. Around blue giants, worlds would be scorched by fierce radiation, their days blinding and brief. But near red dwarfs, a planet might be locked in perpetual twilight, one side forever basking in faint starlight, while the other lies in eternal night. In some systems, two stars orbit one another, creating planets that circle both suns at once. Imagine standing on a surface where twin shadows stretch across alien ground, illuminated by a double sunrise. The variety of stars in Andromeda guarantees a galaxy of endless diversity, each world with its own chemistry, its own atmosphere, its own story written in light. Yet not all worlds have a home. Some planets drift freely between the stars, ejected long ago from their systems during gravitational encounters. These rogue planets wander through eternal darkness, their skies forever black and silent. Their frozen surfaces may conceal hidden warmth, perhaps a faint glow from radioactive decay, or a buried ocean beneath thick ice. Astronomers believe there could be more rogue planets than stars in a typical galaxy, meaning Andromeda might harbor trillions of these unseen travelers. Each one is a lonely voyager, drifting endlessly through the quiet between suns, silent reminders that even in darkness, the universe is alive with possibilities. Andromeda's population of stars is as rich as it is vast. Within its luminous expanse dwell nearly every kind of star known: brilliant blue supergiants, ancient red giants, compact white dwarfs, and neutron stars spinning hundreds of times per second. Alongside shine countless ordinary suns and dim red dwarfs that make up most of the galaxy's mass. This variety forms a living laboratory of stellar evolution.
By observing Andromeda, astronomers can witness every stage of a star's life, from its birth in glowing nebulae to its quiet end as a fading ember. The galaxy's youthful regions shimmer blue with newborn stars, while its older territories glow red and warm. Together, they weave a celestial mosaic, a living portrait of light, energy, and time. Surrounding Andromeda's luminous disk are hundreds of globular clusters, dense spherical gatherings of ancient stars that orbit like shining satellites. Each cluster contains hundreds of thousands of suns, packed within just a few dozen light-years. These are among the oldest stars in existence, born when the universe itself was young. Their soft golden glow carries the memory of cosmic dawn. Studying these clusters allows astronomers to peer back billions of years, revealing how Andromeda first formed and grew. They drift like a halo of jewels around the galaxy, the quiet guardians of its history, preserving the record of a time when the first stars began to shine. Among them, some clusters stand out as truly extraordinary. One in particular, known as G1 or Mayal 2, is not only Andromeda's largest, but one of the most massive star clusters ever discovered. Containing several million stars bound tightly by gravity, it's brighter and denser than many small galaxies. Astronomers believe G1 may be the surviving core of a dwarf galaxy that Andromeda absorbed long ago, its outer layers stripped away, leaving only a brilliant heart of ancient suns. Such clusters are fossils of cosmic history, remnants of past mergers and collisions that shaped Andromeda's present form. Even in their calm appearance, they hold the story of creation, endurance, and transformation written in their starlight. Yet some of these clusters behave strangely. Their stars move in unexpected patterns, spinning faster or slower than gravity alone should permit. Some appear slightly elongated or distorted, as if something invisible were tugging on them. Scientists suspect the influence of dark matter, or perhaps the lingering effects of past galactic encounters. These peculiar motions are like fingerprints left by ancient cosmic events, the merging of two clusters, the ripple of a nearby explosion, or the silent passing of another galaxy. Each cluster tells its story in the slow, steady language of gravity and time, and by studying them, astronomers decode the hidden history of Andromeda's evolution. Beyond its stars and clusters, Andromeda hides another unseen marvel, a vast magnetic field stretching thousands of light-years across its spiral arms and halo. Though invisible, radio telescopes have revealed elegant magnetic lines curving gracefully through the galaxy, following the flow of gas and stars. This immense magnetic web acts like a galactic heartbeat. It guides the motion of charged particles, shapes interstellar clouds, and may even influence how stars are born. It's thought to arise from the rotation of Andromeda's disk, combined with the movement of ionized gas, a natural dynamo that powers the galaxy's invisible architecture. Through this field, cosmic rays, high-energy particles racing through space, are steered and scattered. Instead of moving randomly, they spiral along magnetic paths, colliding with gas and dust to produce faint radio and gamma-ray glows detectable from Earth. These emissions allow scientists to trace the shape and strength of Andromeda's magnetic field and understand how energy moves through a galaxy on the grandest scales. It's a quiet interplay, invisible yet profound, between particles and magnetism, between chaos and order. In this delicate balance, even unseen forces help shape the rhythm of an entire galaxy. Andromeda also shines in gamma rays, the most energetic form of light. When astronomers observed it through space-based gamma-ray telescopes, they found mysterious signals coming not from stars, but from seemingly empty regions. One theory suggests these emissions might be caused by the interactions or decay of dark matter particles, a phenomenon still unconfirmed but deeply intriguing. Another explanation is that the radiation comes from cosmic rays accelerated by the galaxy's powerful magnetic fields. Whatever the cause, these faint flashes of energy remind us that even the calmest-looking galaxy hides storms of unimaginable power within its depths. If the gamma rays truly come from dark matter interactions, Andromeda could be our natural laboratory for unlocking one of the universe's greatest mysteries. Detecting such signals would not only confirm dark matter's existence, but also reveal how it shapes galaxies across cosmic time. Beneath its visible beauty, Andromeda hums with hidden energy, a silent orchestra of magnetism, radiation, and gravity working in harmony. When astronomers peer deeper using X-ray telescopes, another hidden layer emerges. Andromeda glows with countless points of intense radiation, the final echoes of dead stars. Neutron stars, white dwarfs, and black holes consume surrounding material, heating it to millions of degrees until it radiates in X-rays. Between these remnants drift vast clouds of superheated gas, evidence of ancient supernovae and ongoing cycles of death and rebirth. Through these X-ray views, astronomers glimpse both the violence and the renewal that define Andromeda's evolution. Every burst of energy, every flicker of light tells the same eternal story, that even in the vast stillness of the cosmos, nothing ever truly ends. Among the countless points of glowing X-ray light scattered across the Andromeda Galaxy, a few burn with exceptional brilliance. These radiant beacons are believed to be binary systems, pairs where a black hole and a companion star are locked in a deadly gravitational dance. As the black hole pulls matter from its neighboring star, that stolen material spirals inward, forming a blazing accretion disk. Heated to unimaginable temperatures, it releases torrents of X-rays before vanishing beyond the black hole's event horizon. Each of these systems is a cosmic stage of creation and destruction, a miniature drama playing out across light years. Here, gravity and motion weave together, pushing the limits of both energy and endurance. Even from millions of light years away, their brilliance tells the story of extreme physics, a reminder that the most violent forces in the universe can also produce the most mesmerizing light. But Andromeda's story doesn't end with black holes. Its history is written in waves of starbirth and renewal, cycles of intense creation followed by quiet calm. Over billions of years, the galaxy has gone through powerful bursts of star formation, when countless suns ignited in rapid succession, flooding its spiral arms with young blue brilliance. Astronomers believe these starburst episodes were triggered by close encounters and collisions with neighboring galaxies. Each gravitational interaction compressed Andromeda's massive gas clouds, igniting waves of creation that reshaped the galaxy's very structure. Between these storms of birth came quieter eras, moments of cosmic rest where the galaxy cooled, settled, and prepared for the next cycle. This rhythmic pattern of activity and stillness is like a heartbeat of the cosmos, pulsing steadily across time. Every star born during those bursts carries the legacy of those ancient cosmic encounters, each one a glowing memory of the galaxy's ever-changing vitality. These bursts, however, were often the direct result of galactic mergers, titanic collisions that, while destructive, gave rise to new creation. Galaxies are not lonely travelers. They frequently interact, collide, and merge, reshaping one another in the process. Andromeda has likely consumed many smaller galaxies in its lifetime, each collision leaving behind a trail of debris and a renewed spark of life. Evidence of these ancient encounters lingers in the galaxy's warped disk and in the faint streams of stars stretching far beyond its visible boundaries. These remnants are not scars of destruction, they're the birthmarks of growth, proof that Andromeda has been forged through endless transformation.
Beyond its bright spiral arms lies a vast, mysterious halo, glowing faintly with the memories of long-forgotten collisions. Wisps and arcs of stars drift silently there, remnants of galaxies torn apart and absorbed eons ago. Each one is a ghostly thread in the fabric of space, a fossil record of cosmic evolution. By studying their movements, astronomers can retrace Andromeda's entire life story, mapping how it grew and evolved through time. These stellar streams, delicate trails stretching hundreds of thousands of light years, act like the ancient ruins of a galactic civilization. Each one whispers of the galaxies that came before, of destruction and renewal, of an endless cycle that built the grand spiral we see today. Andromeda's stellar halo is far larger than anyone once imagined. Once thought to end where its visible light fades, it's now known to stretch nearly halfway to our own Milky Way. Within this enormous region lie faint stars, ancient clusters, and thin clouds of hot gas, a sprawling envelope of influence that redefines what we mean by a galaxy's true edge. Inside this halo, stars of different ages coexist. Some are among the oldest in the universe, formed when galaxies were just beginning to emerge from cosmic darkness. Others are much younger, recent arrivals from smaller galaxies that have merged with Andromeda. This vast mixture of ages reveals that the halo is not static, but alive with motion and change, constantly reshaped by the slow dance of gravity. It's both a museum of the ancient universe and a workshop of new creation, where the past and present of cosmic evolution coexist. Farther still, the halo blends seamlessly into intergalactic space. There's no sharp boundary, only a gradual fading of light until Andromeda's influence melts into the vast cosmic web. Here, drifting clusters and solitary stars wander freely, caught between the pull of galaxies and the quiet tug of the universe beyond. It's a reminder that galaxies are not isolated islands, but part of a vast connected structure stretching endlessly across the cosmos. Among the halo's many stars are some older than our own sun by billions of years. These ancient suns began shining when the universe itself was still young. Their light, unchanged for eons, carries the record of creation, encoded in their faint golden glow. By studying them, astronomers peer backward through time, glimpsing the early moments of the cosmos before heavy elements even existed. And yet, amidst all this ancient starlight, new stars are still being born. In the spiral arms of Andromeda, glowing nebulae serve as cradles of creation, where gas and dust collapse under gravity to ignite fresh suns. These young stars blaze in hues of pink, red, and blue, illuminating the galaxy's ever-renewing cycle. Each one forms from material recycled from countless generations before, a reminder that even after billions of years, creation in the universe never truly ends. The very chemical makeup of Andromeda's stars tells this story of evolution. Its oldest stars contain only hydrogen and helium, the raw ingredients of the early cosmos. But younger ones reveal traces of carbon, oxygen, iron, and even gold, all born in the fiery deaths of earlier stars. Over time, these supernovae enrich the galaxy, spreading the seeds of new life and new worlds. In this endless cycle of birth, death, and rebirth, Andromeda stands as a living chronicle of the universe's journey, a place where the echoes of ancient creation blend with the promise of new beginnings.
In the vast expanse of Andromeda, a silent transformation has been unfolding for billions of years, a cosmic alchemy where simple hydrogen becomes the foundation of life itself. The oxygen we breathe, the carbon that shapes our bodies, and the iron flowing through our blood all trace their origins to these ancient stellar furnaces. Andromeda's soft radiance is not just the light of distant suns, it is the shimmering evidence of an endless cycle of creation. This great galaxy is a vast alchemist, forever transforming the simple into the complex, forging the elements that build worlds and life itself. Each generation of stars enriches the next, scattering carbon, oxygen, and metals across the interstellar sea.
Planets born around newer stars inherit these elements, rocky worlds with metallic hearts, clouds of water vapor and methane, perhaps even oceans glimmering beneath alien skies. Though we cannot yet see these distant worlds, the light from their stars carries the faint fingerprints of the materials that shape them. In this way, Andromeda reflects our own Milky Way, a galaxy filled with the raw ingredients of life, scattered like seeds across billions of suns. Each system drifts quietly in the dark, a hidden possibility waiting to be found. To the naked eye, Andromeda seems steady and constant. Yet, with precise instruments, astronomers can see that its brightness subtly changes over long stretches of time. These delicate variations come from supernovae, pulsating stars, and drifting clouds of dust and gas. Some regions brighten as new clusters are born, while others dim as massive stars fade. Even interstellar dust reshapes the galaxy's glow, revealing that Andromeda is not still. It breathes slowly, through cycles of creation and decline. These faint pulses mark the galaxy's heartbeat, a rhythm measured not in seconds, but in ages. Across its immense spiral disk, light brightens and fades in a grand, slow dance that unfolds over millions of years. Waves of gas collapse into stars, flare with brilliance, and then rest as the fuel is spent. The galaxy inhales and exhales light, creating and resting in a timeless balance. Andromeda itself rotates through space, an immense, graceful motion invisible to the eye. Astronomers discovered its spin by studying the color of its light. One side drifts slightly toward us, glowing faintly blue, while the other moves away, blushing red. This reveals that the galaxy's billions of stars are all orbiting a common center, a supermassive black hole. Each point of light we see is part of this grand rotation, a fragment of a vast celestial wheel turning with serene precision. One full revolution takes hundreds of millions of years. Entire species could rise and vanish on distant worlds before Andromeda completes even a single turn. Yet the pattern remains unfaltering, a testament to cosmic harmony. Even as its stars move, Andromeda's majestic spiral arms have held their graceful form for billions of years. These arms are not fixed lines of stars, but waves of density moving through the galactic disk, ripples of creation, where clouds of gas are pressed together, ignite, and drift onward. The pattern remains eternal, a stable harmony sustained by gravity, motion, and time itself. Nestled just beneath Andromeda's bright disk lies its loyal companion, Messier 32, a compact galaxy of ancient suns gathered tightly together. Astronomers believe Andromeda's immense gravity once stripped away its outer layers during past encounters, shaping both galaxies in the process. Nearby, Messier 110 drifts gently through Andromeda's gravitational field, glowing faintly with the red light of old stars. In time, these small galaxies will spiral inward, merging with Andromeda, their stars absorbed into its vast halo. Such mergers are quiet but powerful, the slow uniting of galaxies over billions of years. Trails of stars, like pale rivers of light, mark where smaller galaxies once were, now stretched and woven into Andromeda's growing body. It is through these graceful collisions that galaxies evolve and renew themselves. What once was separate becomes one. Today, the smaller companions of Andromeda already show signs of its pull. Their shapes are stretched and distorted, leaving behind ghostly streams of stars. These threads, though faint, reveal the invisible presence of dark matter, the unseen gravity shaping the galaxy's structure. What we witness is not destruction, but transformation, the universe endlessly reshaping itself, guided by its own quiet order. Together they drift through the cosmic sea, bound by gravity, moving slowly toward an eventual union. The galaxies of the local group drift together through the dark, bound by gravity's invisible threads. Spanning millions of light years, this quiet cluster moves as a single, intricate system,
a web of motion and connection that shapes the fate of every galaxy within it. Here, galaxies merge, trade material, and tug gently on one another's paths. At the heart of this gathering, Andromeda reigns as the largest, its gravitational pull extending far beyond its luminous edges. The local group is our cosmic neighborhood, a calm corner of the universe where galactic stories weave together like stars in a single vast constellation. Alongside Andromeda lies the Milky Way, our home galaxy, and dozens of smaller companions. Some of these dwarfs are irregular clouds of gas and stars. Others are compact spheres of ancient suns, drifting through space on orbits that last billions of years. Sometimes they pass too close to their larger neighbors and are slowly torn apart, their stars scattered into the halos of grander systems. Though small, these dwarf galaxies are the building blocks of the universe, adding their light and matter to the growth of giants. Together, the Milky Way and Andromeda command dozens of companions, forming a miniature ecosystem of cosmic relationships. Their delicate balance of attraction and motion reflects the quiet harmony that governs the entire universe, the same laws that bind planets to stars and stars to galaxies. These galaxies do not wander aimlessly through the void. They orbit a shared center of mass, a point defined by the combined weight of all within the group. Neither Andromeda nor the Milky Way sits at that exact center. Instead, both revolve around it in vast, graceful arcs, their smaller companions following behind like dancers tracing invisible lines of gravity. To imagine this motion is to picture a celestial dance, each galaxy following its path, yet all turning together around a center that exists not as an object, but as balance itself, a perfect stillness that defines the motion around it. Yet even the local group is not still. It too drifts slowly through the depths of space, drawn toward a greater gathering, the Virgo cluster. This vast migration, imperceptible to human senses, yet measured by instruments, is part of the immense flow of matter across the universe. Everything moves towards something else, drawn together by gravity over unimaginable distances. The local group's journey toward the Virgo cluster will take billions of years, a gentle pilgrimage across the grand tapestry of the cosmic web, where galaxies are not isolated islands, but part of a boundless network. The forces at play are subtle yet persistent, shaping the universe with quiet determination. Our entire galactic neighborhood drifts like a leaf carried by an invisible current, part of an endless flow that connects all creation. Beyond the local group lies the Virgo supercluster, an enormous structure containing thousands of galaxies, stretching across more than 100 million light-years. Within it, clusters and groups gather like luminous beads along filaments of cosmic matter, forming one of the great threads in the web of existence. At its heart lies the Virgo cluster itself, glowing with the light of countless suns. Our local group drifts near its edge, slowly drawn inward by gravity's steady pull. But even this supercluster is not alone. It too is part of something greater. Every cluster, every galaxy, every star participates in this vast architecture of connection. To gaze upon the Virgo supercluster is to glimpse the immensity of existence itself, where galaxies shrink to mere points of light scattered through an endless cosmic ocean. Within our corner of this great structure, two galaxies shine brightest: Andromeda and the Milky Way. Each contains hundreds of billions of stars, glowing softly across the void. From Andromeda's perspective, our Milky Way would appear much the same, a sprawling spiral of starlight surrounded by smaller companions drifting through the dark. Bound by their mutual gravity, the two are slowly drawing closer, their destinies intertwined. One day, far in the future, they will merge, uniting into a single magnificent galaxy that carries the legacy of both. Their light, shining side by side across the ages, reminds us that beauty and motion are inseparable.
two expressions of the same cosmic harmony. Through Andromeda and the Milky Way, the universe reveals its deepest truth, that nothing stands alone and everything, from the smallest star to the grandest cluster, moves together in the endless rhythm of creation.
Where you can direct a voice, create realistic dialogue, and so much more. Edit these placeholders to get started.
The galaxies of the local group drift together through the dark, bound by gravity's invisible threads. Spanning millions of light years, this quiet cluster moves as a single, intricate system, a web of motion and connection that shapes the fate of every galaxy within it. Here, galaxies merge, trade material, and tug gently on one another's paths. At the heart of this gathering, Andromeda reigns as the largest, its gravitational pull extending far beyond its luminous edges. The local group is our cosmic neighborhood, a calm corner of the universe where galactic stories weave together like stars in a single vast constellation. Alongside Andromeda lies the Milky Way, our home galaxy, and dozens of smaller companions. Some of these dwarfs are irregular clouds of gas and stars. Others are compact spheres of ancient suns, drifting through space on orbits that last billions of years. Sometimes they pass too close to their larger neighbors and are slowly torn apart, their stars scattered into the halos of grander systems. Though small, these dwarf galaxies are the building blocks of the universe, adding their light and matter to the growth of giants. Together, the Milky Way and Andromeda command dozens of companions, forming a miniature ecosystem of cosmic relationships. Their delicate balance of attraction and motion reflects the quiet harmony that governs the entire universe, the same laws that bind planets to stars and stars to galaxies. These galaxies do not wander aimlessly through the void. They orbit a shared center of mass, a point defined by the combined weight of all within the group. Neither Andromeda nor the Milky Way sits at that exact center. Instead, both revolve around it in vast, graceful arcs, their smaller companions following behind, like dancers tracing invisible lines of gravity. To imagine this motion is to picture a celestial dance, each galaxy following its path, yet all turning together around a center that exists not as an object, but as balance itself, a perfect stillness that defines the motion around it. Yet even the local group is not still. It too drifts slowly through the depths of space, drawn toward a greater gathering, the Virgo cluster. This vast migration, imperceptible to human senses, yet measured by instruments, is part of the immense flow of matter across the universe. Everything moves towards something else, drawn together by gravity over unimaginable distances. The local group's journey toward the Virgo cluster will take billions of years, a gentle pilgrimage across the grand tapestry of the cosmic web, where galaxies are not isolated islands, but part of a boundless network. The forces at play are subtle yet persistent, shaping the universe with quiet determination. Our entire galactic neighborhood drifts like a leaf carried by an invisible current, part of an endless flow that connects all creation. Beyond the local group lies the Virgo supercluster, an enormous structure containing thousands of galaxies stretching across more than 100 million light-years. Within it, clusters and groups gather like luminous beads along filaments of cosmic matter, forming one of the great threads in the web of existence. At its heart lies the Virgo cluster itself, glowing with the light of countless suns. Our local group drifts near its edge, slowly drawn inward by gravity's steady pull. But even this supercluster is not alone. It too is part of something greater. Every cluster, every galaxy, every star participates in this vast architecture of connection. To gaze upon the Virgo supercluster is to glimpse the immensity of existence itself, where galaxies shrink to mere points of light scattered through an endless cosmic ocean. Within our corner of this great structure, two galaxies shine brightest, Andromeda and the Milky Way. Each contains hundreds of billions of stars glowing softly across the void. From Andromeda's perspective, our Milky Way would appear much the same, a sprawling spiral of starlight surrounded by smaller companions drifting through the dark. Bound by their mutual gravity, they are slowly drawing closer, their destinies intertwined. One day, far in the future, they will merge, uniting into a single magnificent galaxy that carries the legacy of both. Their light, shining side by side across the ages, reminds us that beauty and motion are inseparable, two expressions of the same cosmic harmony. Through Andromeda and the Milky Way, the universe reveals its deepest truth, that nothing stands alone, and everything, from the smallest star to the grandest cluster, moves together in the endless rhythm of creation.
Studying Andromeda offers more than distant observation. It's a window into the story of how galaxies live, change, and evolve. Because it lies so close to us in cosmic terms, astronomers can examine it in exquisite detail, tracing the entire arc of its existence. Every star within Andromeda carries clues about its past, how it formed, how it has transformed, and how galaxies everywhere grow through cycles of creation and renewal. By observing its spiral arms, its glowing halo, and the vast regions where new stars are born, scientists can compare its history to that of our own Milky Way. Each discovery in Andromeda is also a reflection of ourselves, a reminder that galaxies recycle their material through generations of stars, transforming what once burned into the light that will one day shine again. In Andromeda, we see not just what has been, but what will be. It stands as a living example of cosmic evolution, unfolding quietly before our eyes, a mirror held up to the universe's own becoming. To study it is not merely to look outward, but to participate in a shared story written in the language of starlight. Andromeda also gives us a glimpse of our own galaxy's future. Over the next 4 billion years, gravity will draw the Milky Way and Andromeda together in a slow, graceful embrace. When that moment comes, the night skies of any surviving world will blaze with light as two great spirals merge and reshape. Though the stars themselves will not collide, separated by vast distances, their orbits will shift into new patterns of beauty. Out of their union, a single, majestic elliptical galaxy will emerge, brighter and grander than either predecessor. This is not a story of destruction, but of transformation, a cosmic dance where two immense spirals become one. In Andromeda's shimmering glow, we glimpse our destiny written across the heavens, a promise of change that is both gentle and eternal. Through generations, telescopes have revealed Andromeda in ever greater detail. What early observers once saw as a faint cloud of light has now unfolded into a masterpiece, swirling lanes of dust, rivers of gas, and clusters of thousands of stars. Each new wavelengths of observation, radio, infrared, ultraviolet, and X-ray, unveils another hidden layer of structure and energy. The closer we look, the deeper the mystery becomes. The more precisely we see, the more we realize how much remains unseen, as if the galaxy reveals itself one heartbeat at a time. Andromeda reminds us that curiosity and knowledge are endless companions, and that discovery is a journey with no final destination. Even as technology advances, Andromeda remains within reach for anyone who looks up. Under a clear, dark sky, it is bright enough to be seen without a telescope, a pale, elongated glow softly shining against the darkness.
Through binoculars or a small camera, its central bulge appears surrounded by delicate spirals of light. All around the world, amateur astronomers capture its image from backyards and quiet hillsides, layering long exposures to reveal its graceful form. Each photograph records light that began its journey over 2 million years ago, long before humans ever walked the Earth. To witness it is to connect directly with the vastness of the cosmos, to feel that the universe is not unreachable, but always quietly present above us. The Andromeda glow becomes a symbol of wonder within reach, a bridge between curiosity and infinity. For those who pause to look, even for a moment, the galaxy becomes a silent companion in the night, whispering stories written in ancient light. When you gaze upon Andromeda, the photons that touch your eyes began their voyage before human history began. That light carries with it the record of countless suns, their births, their deaths, and the slow breathing of cosmic time. In its glow lies the memory of creation itself. The same atoms that shine within Andromeda's stars flow through our own bodies, remnants of the same universal source. Its light is both distant and intimate, a reflection of our origins and destiny intertwined. Each time its faint shimmer reaches Earth, it reminds us that we are part of a story older and grander than life itself. To watch Andromeda is to witness the universe in motion, a cosmos that never rests, constantly creating, transforming, and renewing itself. Each photon carries the echo of that eternal rhythm. Its light tells us that existence itself is a kind of movement, that everything is connected through gravity, energy, and time. To see Andromeda is to watch creation unfolding, an unbroken story written across billions of years. It is both a reminder and a promise that the universe is still becoming, and that we are part of its gentle and endless expansion. And as the glow of Andromeda fades from your mind, let yourself drift with it into the quiet stillness of space. Imagine floating beyond the Milky Way, beyond the reach of any single star, where only the soft radiance of galaxies lights the dark. There, everything moves in calm harmony. The stars are silent, yet their light hums softly in your thoughts, a reminder that even in vastness, there is peace. The universe does not hurry. It expands. It changes. It breathes, always with patience. Galaxies turn with grace. Stars are born from quiet clouds of gas. Time itself unfolds like a slow tide upon an infinite shore. And you are part of that same rhythm. The atoms within your body once drifted through stars like those you've just imagined. Their warmth burns within you still, a spark of that ancient fire. So let your breath follow that cosmic rhythm. Let your thoughts settle into the silence between the stars. The universe asks nothing of you but rest. Its beauty is enough. Its motion continues, whether your eyes are open or closed. Somewhere, the light of Andromeda is still crossing the distance towards us, calm, steady, and timeless. By the time it reaches our world, you will already be far away in dream, floating peacefully among the stars that shaped you. Good night.
Not every star in Andromeda mirrors the familiar warmth of our sun. Some are colossal blue giants, blazing with intense ultraviolet light, burning so fiercely that they exhaust their fuel in just a few million years. Others are tiny red dwarfs, cool and dim,
capable of glowing softly for trillions of years, long after every other star we know has faded away. Planets orbiting these stars would live under entirely different skies. Around blue giants, worlds would be scorched by fierce radiation, their days blinding and brief. But near red dwarfs, a planet might be locked in perpetual twilight, one side forever basking in faint starlight, while the other lies in eternal night. In some systems, two stars orbit one another, creating planets that circle both suns at once. Imagine standing on a surface where twin shadows stretch across alien ground, illuminated by a double sunrise. The variety of stars in Andromeda guarantees a galaxy of endless diversity, each world with its own chemistry, its own atmosphere, its own story written in light. Yet not all worlds have a home. Some planets drift freely between the stars, ejected long ago from their systems during gravitational encounters. These rogue planets wander through eternal darkness, their skies forever black and silent. Their frozen surfaces may conceal hidden warmth, perhaps a faint glow from radioactive decay, or a buried ocean beneath thick ice. Astronomers believe there could be more rogue planets than stars in a typical galaxy, meaning Andromeda might harbor trillions of these unseen travelers. Each one is a lonely voyager, drifting endlessly through the quiet between suns. Silent reminders that even in darkness, the universe is alive with possibilities. Andromeda's population of stars is as rich as it is vast. Within its luminous expanse dwell nearly every kind of star known: brilliant blue supergiants, ancient red giants, compact white dwarfs, and neutron stars spinning hundreds of times per second. Alongside shine countless ordinary suns and dim red dwarfs that make up most of the galaxy's mass. This variety forms a living laboratory of stellar evolution. By observing Andromeda, astronomers can witness every stage of a star's life, from its birth in glowing nebulae to its quiet end as a fading ember. The galaxy's youthful regions shimmer blue with newborn stars, while its older territories glow red and warm. Together, they weave a celestial mosaic, a living portrait of light, energy, and time. Surrounding Andromeda's luminous disk are hundreds of globular clusters, dense spherical gatherings of ancient stars that orbit like shining satellites. Each cluster contains hundreds of thousands of suns, packed within just a few dozen light years. These are among the oldest stars in existence, born when the universe itself was young. Their soft golden glow carries the memory of cosmic dawn. Studying these clusters allows astronomers to peer back billions of years, revealing how Andromeda first formed and grew. They drift like a halo of jewels around the galaxy, the quiet guardians of its history, preserving the record of a time when the first stars began to shine. Among them, some clusters stand out as truly extraordinary. One in particular, known as G1 or Mayal 2, is not only Andromeda's largest, but one of the most massive star clusters ever discovered. Containing several million stars bound tightly by gravity, it's brighter and denser than many small galaxies. Astronomers believe G1 may be the surviving core of a dwarf galaxy that Andromeda absorbed long ago, its outer layers stripped away, leaving only a brilliant heart of ancient suns. Such clusters are fossils of cosmic history, remnants of past mergers and collisions that shaped Andromeda's present form. Even in their calm appearance, they hold the story of creation, endurance, and transformation written in their starlight. Yet some of these clusters behave strangely. Their stars move in unexpected patterns, spinning faster or slower than gravity alone should permit. Some appear slightly elongated or distorted, as if something invisible were tugging on them. Scientists suspect the influence of dark matter, or perhaps the lingering effects of past galactic encounters. These peculiar motions are like fingerprints left by ancient cosmic events. The merging of two clusters, the ripple of a nearby explosion, or the silent passing of another galaxy. Each cluster tells its story in the slow, steady language of gravity and time, and by studying them, astronomers decode the hidden history of Andromeda's evolution. Beyond its stars and clusters, Andromeda hides another unseen marvel, a vast magnetic field stretching thousands of light-years across its spiral arms and halo. Though invisible, radio telescopes have revealed elegant magnetic lines curving gracefully through the galaxy, following the flow of gas and stars. This immense magnetic web acts like a galactic heartbeat. It guides the motion of charged particles, shapes interstellar clouds, and may even influence how stars are born. It's thought to arise from the rotation of Andromeda's disk, combined with the movement of ionized gas, a natural dynamo that powers the galaxy's invisible architecture. Through this field, cosmic rays, high-energy particles racing through space, are steered and scattered. Instead of moving randomly, they spiral along magnetic paths, colliding with gas and dust to produce faint radio and gamma-ray glows detectable from Earth. These emissions allow scientists to trace the shape and strength of Andromeda's magnetic field and understand how energy moves through a galaxy on the grandest scales. It's a quiet interplay, invisible yet profound, between particles and magnetism, between chaos and order. In this delicate balance, even unseen forces help shape the rhythm of an entire galaxy. Andromeda also shines in gamma rays, the most energetic form of light. When astronomers observed it through space-based gamma-ray telescopes, they found mysterious signals coming not from stars, but from seemingly empty regions. One theory suggests these emissions might be caused by the interactions or decay of dark matter particles, a phenomenon still unconfirmed but deeply intriguing. Another explanation is that the radiation comes from cosmic rays accelerated by the galaxy's powerful magnetic fields. Whatever the cause, these faint flashes of energy remind us that even the calmest-looking galaxy hides storms of unimaginable power within its depths. If the gamma rays truly come from dark matter interactions, Andromeda could be our natural laboratory for unlocking one of the universe's greatest mysteries. Detecting such signals would not only confirm dark matter's existence, but also reveal how it shapes galaxies across cosmic time. Beneath its visible beauty, Andromeda hums with hidden energy, a silent orchestra of magnetism, radiation, and gravity working in harmony. When astronomers peer deeper using X-ray telescopes, another hidden layer emerges. Andromeda glows with countless points of intense radiation, the final echoes of dead stars. Neutron stars, white dwarfs, and black holes consume surrounding material, heating it to millions of degrees until it radiates in X-rays. Between these remnants drift vast clouds of superheated gas, evidence of ancient supernovae and ongoing cycles of death and rebirth. Through these X-ray views, astronomers glimpse both the violence and the renewal that define Andromeda's evolution. Every burst of energy, every flicker of light tells the same eternal story, that even in the vast stillness of the cosmos, nothing ever truly ends.
Though the stars themselves will not collide, separated by vast distances, their orbits will shift into new patterns of beauty. Out of their union, a single, majestic elliptical galaxy will emerge, brighter and grander than either predecessor. This is not a story of destruction, but of transformation, a cosmic dance where two immense spirals become one. In Andromeda's shimmering glow, we glimpse our destiny written across the heavens. a promise of change that is both gentle and eternal. Through generations, telescopes have revealed Andromeda in ever greater detail. What early observers once saw as a faint cloud of light has now unfolded into a masterpiece, swirling lanes of dust, rivers of gas, and clusters of thousands of stars. Each new wavelengths of observation, radio, infrared, ultraviolet, and X-ray, unveils another hidden layer of structure and energy. The closer we look, the deeper the mystery becomes. The more precisely we see, the more we realize how much remains unseen, as if the galaxy reveals itself one heartbeat at a time. Andromeda reminds us that curiosity and knowledge are endless companions, and that discovery is a journey with no final destination. Even as technology advances, Andromeda remains within reach for anyone who looks up. Under a clear, dark sky, it is bright enough to be seen without a telescope, a pale, elongated glow softly shining against the darkness. Through binoculars or a small camera, its central bulge appears surrounded by delicate spirals of light. All around the world, amateur astronomers capture its image from backyards and quiet hillsides, layering long exposures to reveal its graceful form. Each photograph records light that began its journey over 2 million years ago, long before humans ever walked the Earth. To witness it is to connect directly with the vastness of the cosmos, to feel that the universe is not unreachable, but always quietly present above us. The Andromeda glow becomes a symbol of wonder within reach, a bridge between curiosity and infinity. For those who pause to look, even for a moment, the galaxy becomes a silent companion in the night, whispering stories written in ancient light. When you gaze upon Andromeda, the photons that touch your eyes began their voyage before human history began. That light carries with it the record of countless suns, their births, their deaths, and the slow breathing of cosmic time. In its glow lies the memory of creation itself. The same atoms that shine within Andromeda's stars flow through our own bodies, remnants of the same universal source. Its light is both distant and intimate, a reflection of our origins and destiny intertwined. Each time its faint shimmer reaches Earth, it reminds us that we are part of a story older and grander than life itself. To watch Andromeda is to witness the universe in motion, a cosmos that never rests, constantly creating, transforming, and renewing itself. Each photon carries the echo of that eternal rhythm. Its light tells us that existence itself is a kind of movement, that everything is connected through gravity, energy, and time. To see Andromeda is to watch creation unfolding, an unbroken story written across billions of years. It is both a reminder and a promise that the universe is still becoming, and that we are part of its gentle and endless expansion. And as the glow of Andromeda fades from your mind, let yourself drift with it into the quiet stillness of space. Imagine floating beyond the Milky Way, beyond the reach of any single star, where only the soft radiance of galaxies lights the dark. There, everything moves in calm harmony. The stars are silent, yet their light hums softly in your thoughts, a reminder that even in vastness, there is peace. The universe does not hurry, it expands, it changes, it breathes, always with patience. Galaxies turn with grace. Stars are born from quiet clouds of gas. Time itself unfolds like a slow tide upon an infinite shore.
and you are part of that same rhythm. The atoms within your body once drifted through stars like those you've just imagined. Their warmth burns within you still, a spark of that ancient fire. So let your breath follow that cosmic rhythm. Let your thoughts settle into the silence between the stars. The universe asks nothing of you but rest. Its beauty is enough. Its motion continues, whether your eyes are open or closed. Somewhere, the light of Andromeda is still crossing the distance towards us, calm, steady, and timeless. By the time it reaches our world, you will already be far away in dream, floating peacefully among the stars that shaped you. Good night.